Hello, in this video I'm going to solve the questions in Quiz 2 Mathematics 5. The first question. Write down all subsets of this set. Okay, so the first one, of course there is no first one, there is no second one, but if I want to be a little bit organized, I start from the empty set. The empty set should be written using this symbol, or you just open a curly brackets and then nothing inside and then close it. So if you write something like this is not acceptable. This is not the empty set. It is the set containing the empty set. Okay? Or, if you use brackets or square brackets instead of curly brackets, that's not also acceptable because you have to respect the punctuation rules. So considering all these things, I would write the empty set, and then I have one element subsets. The first one includes only one. The second one, for example, includes only two. The third one includes three. Then I will consider two element subsets. So 1 and 2. Another one is 1 and 3. Another one is 2 and 3. And finally, I consider all three element subsets. But of course, I have only one of them, which is the set itself. So 1, 2, 3, 4, 5, 6, 7, 8 subsets. And that is consistent with my previous knowledge about the number of sets, the number of subsets of a set of cardinality n. We know that if a set has n elements, then the number of subsets is 2 to the n. In this case, I have 3 elements, so 2 to the power of 3 becomes 8, and that is exactly my 8 subsets. Question 2. Consider the following sets. We want to determine this set. Okay, so this pair of brackets prioritize this operation, union operation, and this pair of brackets prioritize the intersection operation. After I determine these two sets, I subtract them using the rules of set subtraction. Okay, the first thing that I want to do is to determine A union B. So to determine A union B, I would write the elements within set A, 2, 3, and 4, and then I start appending the elements of set B to what I have written so far, but I have to be careful not to repeat an element. For example, here, when I want to append 2, I see that I have already written 2, so I ignore that. I jump to the second one, 5. 5 is not already here, so I have to write it. So that is A union B. A intersection B is the overlap, the elements in common. The only element that exists in both of them is 2. So 2 is the only element which is both in A and B simultaneously, nothing else. So it is just 2. And then the question mark is the first set, 2, 3, 4, and 5, which is the union, minus the second set, which is the curly brackets of 2. And then the difference is the elements which are in the first set but not in the second set. 2 is both in the first set and in the second set, so I ignore that. But the rest of these elements are only within the first set but not in the second set. So the answer becomes simply this. And that is what I expect you to type in this space below the question. Question number 3. Let U be the set X consisting of all X in the set of natural numbers such that 1 is less than or equal to X less than 10. Be the universal set. Consider the following sets. Determine this set. Okay, so let me write down the universal set in front of our eyes by writing all the elements, because that's not that much. The first element is, of course, 1. The next one is 2, 3, 4, 5, 6, 7, 8, and finally 9. Not 10, because 10 is excluded. Okay, so when I say when I want to calculate this element, when I want to calculate this set, I have to calculate A complement first. Not calculate, I have to determine A complement first and then subtract B from that. And when I got the set, complement it again. So, okay, A complement means the set of all elements within the universal set so that they are not in the set A itself. So I have to take 2, 4, and 9, 2, 4, and 9 from U, and what is left is A complement. So I will write them here. 1, 3, 5, 6, 7, and 8. Yes? So 1, 3, 5, 6, 7, and 8. Okay, that's correct. And now the next step is to determine A complement minus B. A complement minus B means the elements that are in the first set but not in B. A1 is here and there, so it is not acceptable. So 1 is crossed over, 8 is crossed over, and also 2 is crossed over, but there is no 2. So what is left for you is just 3, 5, 6, and 7. So this is A complement minus B. So what I did, I actually crossed 8 and 1. Okay, what is left? 3, 5, 6, and 7. I wrote it here. But now I want to complement it. So what happens? A complement minus B complement means that I am interested in all elements within the universal set, but not these. So what is left for me? Of course, 1 is left, 2 is left, 4 is left, 8 is left, and 9 is left. So that is the answer that I expect you to type in this space below the question. Question number 4. Consider the following sets as you see them here. Which statements is or are false? We have to choose them. Guessing randomly may lead to negative points. Okay, one thing, the good way is to rewrite these sets in a way that you respect the size of these curly brackets in a proper way. So for example, for the first set A, I don't need to be very careful because there's only one pair of curly brackets. But for B, it is better to have these curly brackets, the other curly brackets, a little bit bigger than the one which is inside. So in this way, you can recognize the elements better. And for C, I have a pair of a little bit bigger curly brackets for the other ones, and then I have another element like this, and then even a smaller one like that. So in this way, you can immediately realize that this package as a whole is one element of C, and then you have 2 here. And then we start checking these options one by one. The first one claims the cardinality of A is 1. Yes, in A we have one element, so the cardinality is 1. So this is indeed true. So this shouldn't be chosen because we are going to choose the false ones. B belongs to C. B is this. And as you see, this is repeating itself as one element in C. So that is also true. A is a subset of C. A is this and C is this. If I want to check the subset relation, I need to see if this is the case that every element within the first set, in this case only 2, is an element of the second set, and that is true. Because the only element of A, which is 2, is an element of C. And this means that A is a subset of C is a true statement. So that is also true, and we shouldn't choose it. The next one tells me A belongs to B. And that is also true, because A is this whole expression, and you see that it appears as one single element of B. So A belongs to B is also true. The next one tells you that B is a subset of C. To check this, I have to convince myself, if this is going to be true, of course, that every element of B is an element of C. But that is not the case. For example, 3 is one of the elements of B. But elements of C are either this one as a full package or that one. None of them is equal to 3. So at least this element, which is an element of B, is not in C. So B is a subset of C is false. And Consequently, this is my first choice. The second one tells me that the curly brackets 2 is a subset of C. Okay, but that is exactly the same as A is a subset of C, because curly bracket of 2 has another name A, and we check that this is true, so definitely that one will also be true. The next one, A belongs to C. You see, A is this package, but in C I have two elements. One of them is this one, the other one is this one, but none of them is equal to this. So A belongs to C is false. And this is the second one that we choose. The next one claims the cardinality of C is 2, which is true, because as I told you, this is one element of C and this is another one. So in C there are two elements, so the cardinality is 2, so that is true, we don't choose it. The next one tells you that curly brackets of 2 belongs to C, so it means A belongs to C, because curly brackets 2 is the same name as A. And then we already checked that A belongs to C is false, so this is also false, and this is another one that we have to choose. The next one claims that the intersection between B and C is the curly brackets 2. But is that right? The answer is no, because there is no element in common between B and C. B has these as 3 elements, C has these as 2 elements, but none of them match. Yes, so B intersection C indeed is the empty set, but this is claiming that this is 2, so that is also false, and this is the next one that we have to choose. The next option claims that cardinality of B is 3, which is true. There are 3 elements in B, so that one is true and we don't choose it. The next one claims that B minus C is equal to B itself, and that is also true, because when you say B minus C, you are interested in all elements in B that are not in C. So if I want to do that, so let me write it. For example, when I write B minus C, I open a curly brackets. 3 is in B, not in C, I write it down. Yes, 5 is in B, not in C, I write it down. And then curly brackets 2 is in B, but not in C, I write it down. And then I close the curly brackets. But if I ask you what you see now, you see exactly set B. So this means it becomes B. So B minus C is indeed B, and that is exactly here, so that is also true. So only I have these 4 options that I have to choose for this question. Okay, for this one, only this option works. Yes? Why is that? Because of this pair of brackets, I have to prioritize the union operation, and then when I found the union, I can intersect that union with C. So if I ask you what is, I can do it here. If I ask you to color the region A union B, you have to consider all parts that are actually included in A, B, or both. So what I am doing now is I am coloring for you. I have to be a little bit more careful. I am coloring actually A union B. So this part is nothing except A union B. Now, this blue region is A union B. I want to intersect it with C. It means that I need to find the overlap between the circle representing C and the blue region that I just did it for you. Okay, I hope that you agree with me. This becomes exactly this part. And that part is exactly the shaded region. So this is why you are supposed to choose this as the answer. And hopefully you can convince yourself that none of the other options will actually be represented by that colored region. Question number 6. There are 40 students in a classroom. The students can choose to study one or more of the courses biology, chemistry, and physics. 10 students study all 3 subjects. 15 study biology and chemistry, 20 study biology and physics, 15 study chemistry and physics. Moreover, we know that 30 students study biology, 28 students study physics, and 22 students study chemistry. A student is randomly chosen. The probability that this student studies exactly one of these subjects, rounded to 2 decimal places, is equal to what? Okay. Based on what we learned in the lesson, I hope that you remember the best way of solving these kinds of problems is to invoke the event diagram, draw a Venn diagram here. Okay, so let us say this is my universal set containing all the students within the classroom. Okay, and now I know that there are 3 subjects, so let us say that I put all students studying physics here in this circle, I put all the students studying biology in this circle, and all students studying chemistry in this circle. Okay. And I don't know, is there any student left outside, meaning that is there any student doesn't study any one of these subjects? We don't know yet, but we know that the total number of students in the rectangle is 40, the number of total students. Okay. And if you remember in the lesson, I told you this is if you have information regarding this part, it is better always to start with that part. And then this is exactly what I want. 10 students study all 3 subjects. So if I want to put a number there, I will put 10 there. Yes, there are 10 students there. And then I continue reading. 15 study biology and chemistry. So this is the biology circle. This is the chemistry circle. The overlap between biology and circle is this part. And according to the problem, it should be 15. But 10 of them are already there. So what is left for this portion is only 5. Yes. And then I continue reading. 20 study biology and physics. So between biology and physics, there are 20 students. So it means that the overlap between biology and physics is 20. 10 of the students are here, so what is left for me is just 10 for here. And then I continue reading. We know that 15 study physics and chemistry, so the overlap between physics and chemistry is 15. 10 of them are already here, so 5 is left for there. Okay. But I also know that 30 students in total study biology. So it means the number of students in the biology circle should be 30. 10 is here, 10 is here, 5 is here, so 5 is left for here. So let me write 5 here. And then 28 students study physics. So in the physics circle, I have to have 28 students, 10 of them here, 10 of them here, 5 of them here. So 3 is left for this portion. And finally, for the chemistry, I have 22 students in chemistry circle, 5 here, 10 here, so 2 is left for here. Okay, but now I have to ask myself, is there anyone outside? To understand that, I have to add all these numbers that you see here, so to see if that is less than 40 or not. Of course, in principle, it cannot be greater than 40, otherwise the problem is ill-designed, but let us see. So I have a 10 here, a 10 here, 20, 5 here, 5 here, 30, 5 here, 2 here, 3 here, 40. So you see the total number of people within the circles is 40 and the total number of students is 40, so what is left outside is 0. Okay, now I pick a student randomly. How many options I have in total? 40, and I want to find the chance. So I write a fraction whose denominator is the total number of ways that I can pick a student, which I know is 40. And now I am interested to see how much I have the chance that this student that I picked studies exactly one subject. Okay, study exactly one subject means study exactly physics, or only biology, or only physics. Only chemistry, sorry. Only physics is this part. And there are 3 students there. Only biology is this part. and there are 5 students there. Only chemistry is this part, and there are 2 students there. So that is the probability, which is 10 over 40, which is a quarter, and then it becomes 0.25. So the answer that I expect you to type there is 0.25. Question 7. If the number of subsets of a set of cardinality n is 62 more than the quarter of the number of subsets of a set of cardinality n minus 3, then n is what? Okay, so that's also a very simple question, but what you need to do is to rewrite this English sentence into mathematical in a mathematical language in the form of an equation so that you can solve that equation and find your unknown n. How can I do that? Okay, I myself know from the lesson that if I have a set of cardinality n, the number of subsets is 2 to the n. This is on the one hand, according to my own knowledge. On the other hand, according to the problem, the number of subsets of a set of cardinality n, which is this number, is 62 more. This is equal to 62 more than a quarter of the number of subsets of a set of cardinality n minus 3. Okay, the number of subsets of a set of cardinality n minus 3 for the same reason becomes 2 to the power of n minus 3, and a quarter of them is just simply this. So the only thing that you have to do is to translate this into mathematical notations and then try to solve this equation and find your n. In order to solve this equation, you might do different ways, but one way is to write 2 to the power of n minus 3. A quarter of this is this number divided by 4, which is 2 to the power of n minus 3 divided by 2 to the power 2, which becomes 2 to the power of n minus 3 minus 2, which is n minus 5. So what I will do, I copy and paste the left side, I copy and paste 62, but instead of the second term, I just simply write 2 to the power of n minus 5. Then I move that term to the left, so it becomes 2 to the power of n minus 2 to the power of n minus 5 is 62. And now I factor 2 to the power of minus 2 to the power of minus n minus 5 out. And then what is left for me? This minus sign, I put it here. And then I ask myself, what should I put here and there so that when I multiply this back, I will get this expression? Answer the second one is extremely simple. That is nothing except 1. Why? Because if I multiply back here, 1 times this becomes exactly that. That's okay. But what should I put here? My claim is that that is 2 to the power of 5. That's also correct. Why? Because when I multiply this back, it becomes 2 to the power of minus 5 into to the power of n minus 5 times 2 to the power of 5. It becomes 2 to the power of n minus 5 plus 5, which is 2 to the power of n. And that is exactly what I have. So that's correct. And on the right hand side, I have 62. But if I ask you what that number is, this is nothing except 31, because 2 to the 5th is 32 minus 1 is 31. So I have 31 times 2 to the power of n minus 5 is 62. I divide everything by 31. It becomes 2 to the power of minus 1 is equal to 2. Is that right? Yes. And then if I ask you what is n minus 5 is simply 1. And it means that n is 6. And that is the answer that you are supposed to write down here. Question number 8. Consider the following set. A is equal to the set consisting of all x's inside the set of integers so that the greatest common divisor between x and 60 is 1. So an x is somewhere between 1 and a. If a has 128 subsets, then the smallest integer a is equal to what? Okay, so this is the key point to understand the elements of the set A. I am interested in all integers, of course positive integers, because x should be strictly greater than 1, so that the greatest common divisor between that integer and 60 is 1. So for example, we know that 60 can be factorized as 6 times 10, which if I want to write it in the lowest term, so it becomes 2 times 3 times 2 times 5, which is 2 to the power of 2 times 3 times 5. Okay, so if I have a number, if I have an integer number x, in which at least one of these factors is also a factor, then there is no chance for me to have GCD equal to 1. Okay, and then the smallest number x is 2, because 1 is not acceptable. So let me write that list patiently to understand what it is. I'm not telling you that you have to do it in that way, but this is one way that you can analyze the problem. So the numbers, potential numbers, are two integers greater than 1. Yes, 2, 3, 4, 5, 6, and 8, 9, 10, 11, 12. So let us see how much I have to continue. Okay, be careful. I want to choose those numbers in this list that satisfy this. Okay, and I told you that in the factorization of these numbers, if a number x is acceptable, in its prime numbers, you shouldn't see 2, you shouldn't see 3, you shouldn't see 5. So if I want to do that, this should be dropped from my list because I see a factor of 2 there. This should be dropped in my list. 4 includes a factor of 2. 5 includes a factor of 5. 6 includes a factor of 2, or of course 3. So 7 is the first acceptable one. Because if I put 7 here, GCD between 7 and 60 is definitely 1. Okay. But again, let us continue. So in order to see how much I continue, I need to know how many elements are in there. Okay, because if I do not have any restrictions, I can continue this list forever, and little by little, I can accumulate a lot of numbers there. This is why another piece of information is given in the problem. They have indirectly told you how many elements are there in A by telling you that there are 128 subsets of A. So this means that the number 2 to the power of cardinality of A is 128. But this is just 2 to power 7, so it means the cardinality of A is 7. So it means that I know how many elements are there, and I have found the first one so far. And then I continue this list. Okay, so 8 is not acceptable because it contains a factor of 2. I will not repeat this. 9 is not acceptable. 10 is not acceptable. 11 is the second acceptable one. So far I have 2, but I know that the cardinality of A is 7, so I have to continue. So 12 is not acceptable. So let me write a little bit of them. 13, 14, 15, 16, 17. Okay, so let us see how much we can do now. So 13 is also acceptable. So far 3 elements. 14 is not acceptable. 15 not. 16 not. 17 is acceptable. So far 4. 18 is not acceptable. 19 is. 21 is not acceptable. 20 is not acceptable. 22 is not acceptable. But then 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay, let us stop here. So let's see what happens. 23 is acceptable. So far, how many? 1, 2, 3, 4, 5, 6. But I need 7. So 24 is not acceptable. These are not acceptable. And then this is acceptable. Okay, so 1, 2, 3, 4, 5, 6, 7. So I got my 7 elements of A, the set A. But if you write 29 here, that's not correct because you see this is not including A itself. So the smallest integer A is 30. So what you have to write here is 30. Because if I give you A is 30, 1 is less than X less than 30, you want to respect this condition. And this condition, you exactly find these 7 elements that we discussed about. So the number that you have to type here is not 29, is 30. If it was including A, then of course I would write 29 here. Okay, question number 9. Consider the following sets. The set A consisting of natural numbers so that that natural number is congruent to 3 modulo 9. And B consists of all natural numbers that those numbers are congruent to 3 modulo 6 this time. The sum of the first 3 smallest elements of this set is equal to what? So in order to answer this question, I need to have a good feeling about the elements within A and the elements within B, because then I need to find A minus B and then read the first 3 elements of A minus B and add them up to find the sum. Okay, but in order to do that, let me start with here. So n is congruent to 3 modulo 9. It means that the number on the left minus the number on the right is divisible by the modulo 9. This means that there exists an integer q so that n minus 3 is 9q. In other words, the number n is 9q plus 3. But of course, q is an integer, but n is a natural number. So I cannot choose negative values for q because then I will have negative values for n, and n should be a natural number. So this means the smallest q that I can choose is 0, which gives rise to 3 for n. So let me write the list of A. So A, the first element that I have in A is 3. Then I choose q to be 1. Then it becomes 12. I choose q to be 2. The next one goes 9 units higher, so it becomes 21. I don't know, 30, 39. Let us write some of them: 48, 57, and then 65. Yes, am I right? Every time I have to add 9 units. Let me double check. Yes, so this is not 65, this is 66, 9 units, and then 75, and then I don't know, 84, and this list, of course, forever. Let us keep it open to see how many of them I need. For B, I will do the same thing. So I would write this one. The only difference is that instead of having 9 here, I will have 6. And then, of course, because I want to differentiate between the letter q here and the next one, I use it as q prime. So it becomes 6q prime plus 3. So elements in B are of this type, meaning they are 3 units more than a multiple of 6. And the smallest one is again 3. So if I want to start with that, the first element I would write is 3, but then when I choose 1, I get 9. So I am going 6 units at a time up. So it becomes 9, the next one 15, the next one 23, the next one 29, 35. So let me check. The first one is 3, 9. No, sorry, this I made a mistake. It's 21, 27. 33, 39, 45, 51, 57, and it continues, yes. If I go 6 more, it is 63, and etc. Okay, now what I will do, I want to write A minus B. Means I am interested in all elements that are in A but not in B. So I cannot write this one because 3 is in A and B. The first number that I can write is 12 because 12 is not in the list below. So I will write 12 first. And then what happens? I cannot write 21 because 21 is also here and there. The next one, 30. Can I write 30 here? Yes, 30 I can write it. Because 30 is here but not here. 39 I cannot write, so I have to eliminate that because 39 appears here and there. But 48 I can. 48 is not in my list. and then I would write 48 here. Of course, this list will continue, but I don't need more than that because I just need 3 smallest elements of a minus b that I know that these are these numbers, so the question mark is the sum of them. And this is 90. Oh, sorry, this is 90. And this is the answer that you have to put there. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.